Epilepsy is a common neurological disorder which affects about 1% of the world population. Individuals affected by this suffer from seizures, which are disruptions of normal brain activity caused by excessive firing of the brain cells, which are called neurons. About 1/3 of epilepsy patients do not respond well to conventional drug treatments. This is mainly due to the failure of drugs to cross the blood-brain barrier, which is a natural barrier of the human body to prevent toxic chemicals or other harmful substances from reaching the brain. In order to bypass the blood-brain barrier, researchers from the Bionic Systems group at the University of Cambridge came up with a new idea: an implantable device that directly delivers an anti-epileptic drug onto the affected area of the brain. What are the advantages of targeted drug delivery?
Localized delivery, like we are doing with our device, basically is in the desired region where you actually want the drug to take effect. So you only deliver the drugs to the specific locations where you want the drug to work, and then you can avoid unnecessary responses from areas where the drug is not needed.
In order to detect or predict a seizure, brain activity needs to be monitored continuously. Neurons produce voltages in the form of spiking activity, also called action potentials. Brain sensors can measure action potentials based on changes in electrical potential near the cell body of the neuron. These voltages are then converted into electronic signals to process and interpret the data. If the sensor detects a deviation from normal brain activity, the device can then elicit the drug delivery response. The device consists of a drug reservoir with an electrode, an ion exchange membrane, and a second electrode that interfaces with the targeted brain area. When an electric potential between the two electrodes is applied, charged drug molecules will be transferred across the membrane to the targeted area in the brain. The membrane is designed in such a way that it only allows for the specific drug to move towards the brain and prevents other molecules from diffusing into the opposite direction. When the drug is not needed, simply no electric potential will be applied so that the drug transport stops. This technology has great potential to alleviate suffering, and although it is still in its early steps, it offers a promising alternative to conventional therapeutics and will hopefully be tested in clinical trials in the next few years.